U.S. China competition today has a strange pattern. America talks about chips because chips power AI, advanced weapons, and high-end manufacturing. But America also worries about something less glamorous: rare earths and critical minerals, the materials underneath its high-tech economy. China is called the world's factory, but its deeper anxiety is advanced chips and semiconductor equipment, because they decide whether China can keep moving into frontier technology. So the rivalry can be summarized simply. America restricts China's access to advanced chips. China holds leverage over America's rare earth supply chains. One side controls computing power, the other holds leverage over the material base of modern industry. A supply chain choke point does not always mean you cannot buy something. The real danger is that you cannot decide the timing, quantity, quality, or price when it matters most. In normal times, a contract may work. During a crisis, delivery can slow, prices can jump, and export rules can change. A choke point does not need to shut down a country. It only needs to make a factory miss one component, a weapons system miss one material, or an AI industry miss enough advanced chips. The most dangerous choke point does not cause instant collapse, it slows the speed of upgrading. And in great power competition, speed itself is power. From the American perspective, the rare earth problem is not simply a lack of minerals. The United States and its allies do have resources, but the harder problem is turning minerals into reliable industrial materials. Rare earth ores must be mined, separated, refined, purified, alloyed, and manufactured into high-performance magnets, and China has spent decades building that system. This matters because rare earths appear inside electric vehicle motors, wind turbines, precision-guided weapons, radar systems, robots, drones, satellites, and defense platforms. So Washington sees rare earths not as ordinary rocks, but as hidden joints inside the modern industrial body. Many people ask, if America can buy minerals from other countries, why worry? But that question misses the point. The hard part is not only digging ore out of the ground, it is processing it into materials that high-end manufacturing can actually use. You can find a mine, but that does not mean you can instantly build a mature separation plant, produce stable magnets, or qualify them for defense and aerospace supply chains. Environmental rules, chemical expertise, industrial support, production experience, and cost control take time. That is why rare earth controls make the United States nervous across defense, clean energy, data centers, and advanced manufacturing. America fears that the switch underneath its high-tech system may sit somewhere else. Can America bypass China? Eventually, yes. It can develop domestic mines, invest in allies, and support magnet factories, but a supply chain cannot be replaced by drawing a new line on a map. Rare earth replacement has several barriers: resources, separation, environmental cost, magnet manufacturing, and customer certification. The ore must be suitable for separation, processing must reach industrial purity, environmental rules must be handled, and magnets must be produced at scale. Then defense, aerospace, automotive, and energy customers must certify the material before using it in critical systems. So the United States understands the risk, but a mature, low-cost processing system takes years to build. On the surface, this is about minerals; underneath, it is about industrial accumulation. From China's perspective, the biggest choke point is not rare earths. It is chips. More precisely, it is advanced chips in the upstream semiconductor supply chain. China has one of the world's most complete factory systems, but advanced AI chips, semiconductor equipment, ADA software, high-bandwidth memory, and key materials still depend on a global ecosystem. The rules of that ecosystem are largely shaped by the United States and its allies. America does not need to block China from every chip, it only needs to restrict access to the most advanced computing power. In the AI era, computing power means faster model training, smarter robots, better simulations, and more advanced manufacturing. China's fear is not losing ordinary chips, it is being locked out of advanced computing and advanced manufacturing equipment for too long. Chips are not just one industry. They are the platform underneath AI, smart vehicles, robots, aerospace, machine tools, and defense systems. Without enough advanced chips, China does not stop developing, but the pace can slow. It is like a long-distance race where one runner has professional shoes, while the other runs with extra weight. The chip supply chain is also extremely long. Design needs ADA software, manufacturing needs lithography, etching, deposition, inspection, and metrology. AI chips need advanced packaging in HBM. If one link is blocked, the final capability is affected. That is why China pushes domestic GPUs, ADA software, equipment, materials, and advanced packaging. Chips are a long-term industrial system problem. Many people think the chip problem is about one missing machine or one missing GPU, but the semiconductor industry is not a single line. It is an ecosystem where every layer locks into the others. Design firms need software and IP libraries, fabs need precision equipment, material companies need ultra-pure chemicals, packaging companies need substrates, interconnects, and thermal management. After all that, customers must verify the product again and again. Design without manufacturing cannot deliver a chip, manufacturing without yield cannot control cost, samples without mass production cannot enter real industry. So China's chip choke point is not just about buying advanced chips. It is about rebuilding an industrial ecosystem under pressure. At this point, the logic becomes clear. America's strongest position is in high-end technology rules, chip design tools, semiconductor equipment, AI chips, software, intellectual property, and alliances. China's strongest position is in manufacturing scale, critical material processing, rare earth separation, and magnet production. So America pressures China through the technology upstream. China pressures America through the material base. One side is like the brain. The other is like the bones and blood. The United States uses chip restrictions to slow China's AI and high-end manufacturing. China can use rare earth and critical mineral controls to remind America that high technology still depends on materials. Both sides have strengths, and both sides have vulnerabilities. The real question is who can repair their weakness faster. Which is harder to replace, rare earths or chips? The answer is, both are hard, but in different ways. Chips are hard because of technological height. Advanced nodes, ADA software, lithography machines, HBM, semiconductor equipment, and packaging all require extreme precision and long accumulation. Rare earths are hard because of industrial depth. Mines can be found, and money can be invested, but separation, refining, magnet manufacturing, environmental handling, certification, and mass supply cannot be built overnight. Chips are like a technological mountain. Rare earths are like an industrial maze. With chips, the summit is visible, but the climb is difficult. With rare earths, it may look like mining, but every stage is more complex than it appears. Both sides know the other side's card is painful, and both know their own weakness must be fixed. The most important part of this supply chain war is not who sanctions whom today, or who retaliates tomorrow. The deeper question is whether America can rebuild critical mineral supply chains, and whether China can rebuild advanced chips under external restrictions. This competition may last 10 years, 20 years, or longer. Because the supply chain is not a shopping list, it is an industrial ecosystem. Having minerals does not mean having materials, having factories does not mean having process know-how, having equipment does not mean having a system. Only a system becomes real national capability. America fears rare earths because high technology still depends on basic materials. China fears chips because a manufacturing power cannot become a technology power without advanced computing. On the surface, this is a trade war. Deep down, it is a war between industrial systems.